record on this computer. Uh, okay, yeah. Okay. So, okay. So welcome everyone. Since Alex is not here today, um, I'm gonna do like a um, poor stand-in for Alex. Okay. Just a couple of announcements real quick, and then I will turn it over to our mysterious guest. Um, okay. So in case you guys missed it last week, Alex actually has a secret talent of composing, and so this is actually his music. Um, and a quick reminder for next week, okay? We're actually starting at 10 a.m. rather than at noon because I have a meeting at noon, so I can't do the Zoom. And then hopefully Alex will be back and he's going to talk about files. And all of these lectures and the problems have already been posted on the forum. And so you can download all of these links both on the main forum and then Alex's specific forum. And so today we have like two very special people, one from Stanford, one from Berkeley. So this is like very reminiscent of the Stanford Berkeley big game. I think like, the Stanford mascots are the tree. I think the Stanford mascot is like some of the ugliest mascots I've ever seen, in college, but that's okay. And then the Berkeley mascot, even though I'm not a Cal grad, I think the Berkeley mascot is much, much cuter. And so, um, before having TJ, okay, like, um, hold on, okay, um, take over, I do want to have you guys take one poll because last week we had talked about maybe um, posting the the files, okay, onto YouTube for posterity. And then there were some concern about privacy. And so my daughter, who has way too much time, actually went over and like cropped out all the faces and names on all of the Zoom files. And so I just wanted to kind of poll the group again, okay, assuming that the faces and names are gone, would you be okay posting these YouTube videos basically onto YouTube so that other people, could have access to them in posterity? Okay, that's good. If there's 100%, that's great. And then the other one is a trivia question. What is the name of like the Berkeley bear? Okay. And so hopefully nobody's going to pick John Harvard because obviously that's the Harvard mascot. And so the right answer, okay, we'll see what the right answer is. So the right answer is actually Asky the bear. Tim is the name of the MIT Beaver. Handsome Dan is the name of the Yale Bulldog. And then Touchdown is the name of the Cornell bear. And then John Harvard is the statue of John Harvard. That's the Harvard mascot. So, and then one other announcement is the Zoom link will remain the same every single week. It will not change. And so definitely feel free to save it and then use it for all of our future meetings. So with that, I will turn it over to our special guest. Thank you very much for doing this, TJ. I'm gonna make you co-host and you will have hopefully screen share privileges.
Sounds good.
I'm gonna stop sharing.
So just to introduce myself first, my name's TJ. I'm was the only full-time developer working on the Code in Place site this year. And I've worked closely with Cameron, who's the head TA, and he's sort of kept me in the loop about this group, and I think it's awesome. And he mentioned that there wasn't someone for today. So I think today we're going to look at assignment 5, which is Infinite Story, which is a really neat assignment. But first, I kind of wanted to give just like a little overview of APIs because that might be a new concept in this assignment. Um, so I have just like a small slideshow, but uh, feel free to interrupt with any questions or if you put them in the chat, let me know. Um, and from there, I think we can get started. So APIs, can everybody see first off? Just want to make sure everybody can see the um, slideshow. Okay,
Yes.
great. It looks like people can. Okay. So APIs, API stands for Application Programming Interface, um, which that acronym doesn't mean too much. In fact, I had to look it up. If you work with them long enough, you will totally forget what it means. But really, what they allow you to do is communicate between two different systems. And commonly, this is between like remote systems. So imagine you manage this site, right? And for most people, the HTML looks exactly the same. Everybody has the same sidebar, the same pictures for the most part, except for a few things. For example, different students might have different roadmaps. Each student has a different profile. Um, Data like this is specific per student, right? And so you need a way to differentiate which students get which data. Um, and so here is where sort of APIs come in. So if you think about this is like the front end, right? So this is what you will see. This is what I'll see on my computer when I open the website up. And then this might be like the back end, which is like the database or where all the information is stored. For example, here it looks like users or customers. We need some way for these to interact. And so that's where APIs come into play. APIs plus the internet are the way that you can sort of request information from like the client's computer, which is yours or my computer. Uh, you can request information from the database and then receive that information. Additionally, you can sort of send data to the database or to a different system to be updated and changed. Um, and then you always get some sort of response back. And so this is how a lot of data on the internet is managed. Every time you sign in anywhere, every time you're really posting anything online, it's all being passed through APIs. It's sort of the communication channels. Um, and so, yeah, in response, you get information, confirmation, or sometimes errors. Um, so again, APIs allow two different systems to interact with each other, and they're often not always connect remote systems via HTTP requests, which we won't get too deep into, but I'll mention later on. And so what does this look like in practice? So I want to, for a moment, go to this site, which is this site is the current location of the International Space Station. Right. And so here we can see it's actually moving slightly about every second. But what's interesting is that you can actually look into any sort of browser can do this. You can, if you sort of right click, you can click inspect, and then you can go up to uh, this arrows and then click network. And you can actually see these are the API requests that your browser is making. So what your browser is doing from your computer, it's sending a little message to the backend. And in this case, the backend is sending back the real-time location of this International Space Station. And so here's sort of the anatomy of Web API. I think I'm mainly focused on Web APIs here because it's what's used in the assignment and also just very common for the most part. Most often, I think if you're programming with APIs, they'll be web APIs. So here's the sort of anatomy. Basically, there's an endpoint, and this looks just like a URL, just like a website. Um, and then your computer can make a request to this, which we'll talk about later, and it will return a result. And the result is actually oftentimes, it can be in different formats, but very often it's in what's called JSON formatting, um, which is JavaScript object notation. And this format is in the same structure as a dictionary. So if we remember dictionaries, we'll do a little bit of review. Dictionaries provide sort of a key value pairing. So each key goes to a value. You can have nested dictionaries, and you can have any sort of types of data in them. Um, and this is important, especially for infinite story, where it's all about nested dictionaries. And so again, looking at this, you can see that your computer will make sort of this request, which we'll look at the details of later, to this endpoint. And then the result will come in this sort of dictionary looking structure, right? Where you have like a curly braces and sort of key value pair. So you see here, we have an outer dictionary that has sort of a success key and a data key. And then within the data key, there's another nested dictionary, which contains things like lat, lon, which are latitude, longitude, altitude, sort of all kinds of data about where this current space station is at the moment. Um, and so now to talk briefly about the OpenAI API, which we'll use in Infinite Story. Um, Sometimes, for example, in the last case, we just need to make a call to the endpoint. But sometimes we need to do more than that. For example, OpenAI needs one, the endpoint, which is the URL, but they also need information about what model type you're prompting and what you're actually asking from the API. And so here, which maybe this is a good time actually to go into Python. So I'm going to stop sharing sort of my slides. And I'm just, before we get into Infinite Story, um, I'm just going to get into a little playground. Great. Okay. So can you see my code? Okay. Great. So let's start with sort of what we just talked about. So important things here are we're importing a library called requests, which is Python's library for interacting with web APIs. We're also importing JSON, which is another library specific to Python um, that's used for sort of parsing that JavaScript object notation, um, which is how the APIs will sort of respond. And then for later, I've imported my OpenAI AI key, but don't worry about that for now. For now, um, we can start with this line, which uses this request library um, very simply to call. It uses this function called .get, um, which actually makes the request via the internet to this endpoint, um, which in this case is the International Space Station current location. And then we can actually print the text of the result. Um, So a very simple program, basically just using Python's request library to make an API call to this endpoint. Um, let's save it first. And you can see here, um, we get this information. Let me see if I can. Oh no, never mind. Well, here we can see we get sort of this dictionary structure again, and I'll try to straighten it out a bit more. But we have these two keys that come in. One is success, which we saw before, and the other is that data object, which has sort of the latitude, longitude, altitude information from the API. So here are using Python, we make a request to the API endpoint and we receive the result. And so where this will come into play in with Infinite Story is we're going to be using the OpenAI API. So now OpenAI, like I said before, it requires a bit more than just calling this endpoint. We actually need to pass in data. And so how we're going to pass in data using Python's request library, um, is we can first establish the OpenAI endpoint. So the endpoint in this case is the chat completions endpoint, and that's sort of dictating what um, type of model we want to call. There are other endpoints that provide AI generated images or sort of other information, but in our case, we want this sort of completions endpoint. And so this sort of dictates like what data we need to pass in and what result we're going to get out. Then, because OpenAI's API is a secure API, it requires an API key. So here's another difference. Whereas with the sort of ISS API, anybody can call it from any computer. OpenAI requires having this API key, which is just a long string of sort of letters and numbers. It looks something like this maybe. Um, if I think I saw someone sent instructions out about how to create an OpenAI account and get this API key. It's just in another file stored as a string uh, like this, and then yeah, it's just some random string of numbers. So that's all this like OpenAI key is, just a string of numbers. And what these headers are doing is it's telling OpenAI's servers like what how we want the response to be in. So we want it to come back in JSON, and it also what our authorization is, which is sort of this key, which is specific to me and my account. So OpenAI will know who's making the call. Um, then in addition to that, we need the data. And so the data is the information that we're passing in to tell OpenAI what like how they should execute the request. So we need to specify a few things. We need to specify what model we want, which in this case we'll do GPT-4o. And then we need to specify sort of the messages that we want to send in. In this case, and so messages takes a list of objects. Each object has a role, which is the responder. So there's system, and then you can also have the role user. We can change it to user. And then content. And that's sort of the question that you're sending to the sort of chat GPT style model, in this case, GPT-4o. And so now that we have the headers and the data and the endpoint, we can make our request, which so we can again sort of use this requests library, but instead of using the get function, which is just for getting information from endpoints that don't require data input, we use instead what's called a post function, which allows us to pass in information. So we can pass in the OpenAI endpoint and then the headers uh, and then the data. Oh, whoops. Data. And so here we don't actually need to do anything because uh, requests knows that the dictionary that we're passing in is a dictionary, and it will convert it to sort of this JSON format, which looks very similar when it passes it to the uh, API. So again, this will call this endpoint with these headers and this data. And then we can print the response text. And here, I'll pause for a minute and go back really quickly to the uh, to the presentation. And so here is what the uh, OpenAI response will be. So in text, OpenAI will respond with this object, and it looks kind of intimidating at first. It's a big object. It's in JSON formatting, which we can convert easily to a dictionary. But just to walk through it, it will give you choices, which is a list of responses by the model. And each choice is an object, and within each choice, there is a message object, and the message object has a content object, which has the text response of the model. And so this is really the information that we want, this message object on line 6. It also gives you some other metadata, like when it was created. This is a timestamp, the ID, the model, the sort of object, which comes from the endpoint, and then some information about how many tokens it returns. But this is more metadata. I think what we're interested in this case is choices. So with that, we can stop and go back to the playground and can comment out this. Oh, interesting. So we've gotten an invalid request. So it said we could not parse the JSON body of your request. Oh, I see. So I think I was wrong. I think instead, we I passed in a data object, but what we should really have passed in is the JSON of this data object, which we can get by using the JSON dumps, which basically takes your dictionary and turns it into a JSON string. So let's try that instead. Oh no, again, bit of an issue. Let's see. Oh, I see. Never mind. What I just told you was wrong. Instance, initially I had data, and then I had JSON, JSON to JSON dumps, but actually we can just use JSON equals data. It will auto format this object as a JSON object. Let's try one more time. Okay, great. So now we've made this request. Um, And as you can see, it comes in the same format as the object we just had. But now, sort of my prompt was respond with some positive emojis. And the first and only choice it gives in this message field and then this content field, we have this sort of list of what I think is very positive emojis. So you can see that this sort of combination of passing information in yielded this result from the model. Um, so that is pretty cool. So at this point, maybe I'll stop and take any questions about sort of what I've gone over in terms of APIs, and then after that, we can hop into Infinite Story. But if nobody has any, we can just go straight.
Um, TJ, I have two questions, okay? Like what could be an API? Because you mentioned that OpenAI could be an API. But what other, I don't know, like the word like format or platform could make an API? Could a Google search engine be an API? That's the first question. Second question is like when you do a query, um, to an API platform, okay, is there like a standard format that your query has to be so that regardless of which API you are querying, whether it's OpenAI, whether it's some other um, platform, it will always recognize the standard format and then the output is always in a standard format too?
Yes, yes. So these are great questions. Great questions. So the answer to the first question, what could be an API? And the answer is pretty much anything. There is a Google Search API. There's also Google Maps API. There's many different weather APIs. Um, Pretty much any information that you can get from online could be formatted as an API. And as a developer, like each API is sort of designed by a developer. So like libraries, like sort of the libraries that you import into your Python script, those libraries contain functions and classes which were written by other developers. In the same way, when I query those endpoints, um, each endpoint has a function on the other end that is actually receiving my query that a developer has written and that is responding in accordance to the information that I passed in. And so so the answer there is pretty much any sort of data passing situation could be an API. In addition to web APIs, like passing data between my computer and a remote server, there's also like operating system APIs, which are what allow, Zoom, for example, to access the microphone and the video camera on your computer, right? Your computer has these APIs that are designed for applications to be built on top of them, and send data between those two components. So I hope that answers the first question. And to the second question, is there some format that you can send it in? Um, the format of like, let's see. For example, here, OpenAI defines this specific format, this like data object, as the data that needs to get passed in order for more information, in order to get the information you need. So actually, each sort of API online has, or not everyone, there are some that don't, and it can be very difficult, but many APIs have documentation. So what I'm showing right now is OpenAI's documentation. And so OpenAI's documentation will give you information about the way that you should call um, their API. So for example, in this code snippet, I was using just Python's built-in requests library, but OpenAI actually has their own library, which we'll use for infinite story. And here they give you functions that you can call directly with the information that I was passing in through data. Um, and in order to call, like to make it easier to make correct calls to their API. So you saw where I had like two small bugs that likely wouldn't have occurred because they've given me like this function and this information. And then this function from the OpenAI library will go back and make that request behind the scenes in a way that's sort of more foolproof and easier to understand. So many online APIs, for example, we can go to like Google Maps uh, and look at their API. Um, so what if we were just going to look at Get Started? Um, so they'll have all this information about sort of like they'll give code snippets on how to integrate it into your code, make calls to the API in a correct way. So the way to reach APIs, there's sort of two levels. The first level is like in what format you send the content. The protocol there for the most part is JSON, but there are other like protocols that other people have created. It's really dependent on um, sort of what API you're using, who developed it, and whatnot. And then there's like the API specific information that you need to pass in, which we just saw was like in OpenAI's case, sort of the prompt and the object type, um, and things like that. Does that help at all?
Yes. So I guess we have a couple other questions in the chat. Do you just want to look at the chat and then answer those,
Sure.
or you want me to like read them off to you?
Yeah, I can totally look.
Okay.
Okay, let's see.
Just go towards the very end, starting from Richard's question. It says, oh,
Okay. How do you find out what an individual
okay,
site
yeah.
or server is
So I
expecting?
guess you kind of went over that. There are documents, right? So
Yeah. So like I said, hopefully the API provider will have documentation online or information about that. Sometimes they don't, and that's quite annoying. And then you can sort of play around and see what information you get back. But sometimes there you're just out of luck. What's the difference between an SSH key and an API? So kind of similar. SSH key is like a similar sort of thing for authentication, kind of like an API key. It's a bit different though. With the API, you're sending a request for information, and then that request is being executed on the back end. When you SSH into a server, you're really sort of creating an open connection with that server, and then the code that you then like write, for example, in the server that you're SSH'd into is run on the on that server. So I guess it's a bit like an API is sort of like a message passing, like I'm sending a letter or I'm sending something and then they'll send me something back. Whereas an SSH is really like I'm sort of like uh, going like running a sort of pipeline to that server and it's running information and sending it back. So they're similar in that you're both sending information back and forth, but an API is more meant for like general use, like pulling data from a database, doing tasks that will be done over and over again, whereas SSHing is more like actually going into a server and more of a personalized thing. Do different roles do anything, and how many kinds of roles are there? Yeah, so there in OpenAI's case, there are three roles. There's like the system role, there's the user role, and there's the assistant role. The system role is what's like the system prompt. It's kind of a prompt given to the model that is from like a third party. The user role is like the prompt given to uh, the model as like the person that the model is talking to. And then the assistant role is the model. So the model will see the assistant as what the model has responded, kind of like it's what they've said. And I don't know exactly how they handle those on the back end. Um, but uh, yeah, that's the general gist.
So, one follow-up question, TJ. So, if you just have like a database, okay, that you can query information from, but the database is certainly not interactive, that doesn't really count as an API, right? Because I think with the API, you have to query stuff and then it has to return information to you. Whereas like a database is kind of static. And so would that count as an API?
Well, so a database itself is not an API per se, but I think it's really that like databases have APIs. It's kind of like the database's mailbox per se. Like if you want to send a message to a database, you send it to the API, and then the API will run code that retrieves information from the database. So it's kind of an intermediary between the sort of client who's trying to get information and the database that is holding the information. And uh, yeah, so it's like a middle layer that allows you to sort of communicate from afar, I guess. Um, okay, great. If there are no more questions, I guess we can jump into the infinite story. So is everybody able to pull up the infinite story document? Actually, maybe we can just look through it together for a moment. I think we have enough time. Um, so so here's the assignment, assignment five. The it goes like this. So in this assignment, it's choose your own adventure game. So if you've ever had one of those games or sort of things where it's like a tree and it's like at any given point you can make a decision and then that will take you down a different path. Um, in this case, you can see here first it says like you are standing at the end of a road before a small brick building. A small stream flows out of the building and down a gully to the south. A road runs up a small hill to the west, and then it gives you three options. Take the road up the hill, walk up to the stream, or knock on the door, and then it says, what do you choose? And then you'll choose one, and then you'll get sort of this next stage of the story, which is sort of fun way to um, go through a unique story. But in this particular case, the goal at the end is to get to the ability to have a never-ending story. Usually these stories have an end because it's really hard to generate infinite scenes. But now with ChatGPT and the OpenAI API, we can make a request to OpenAI to get another scene. So instead of being at the end, we'll just wait for the next scene, and then you can sort of see what OpenAI comes up with. So there are a lot of different parts of this assignment. One is like the loading of data from files. Another is the sort of nested dictionary aspect and looking at how to parse a very nested dictionary. And then another is the API call to OpenAI. So this first step, milestone one, is loading the story. Um, and then there's a warm up here. The warm up is to find the dead ends in the story. And a dead end is just a scene where it has no sort of like there isn't a scene, like it'll make more sense once we look at the data, for example. So here's how this story JSON file is structured. Basically, there's a plot, which is just a string, some information about the story in general, and then there are scenes. And so each scene has a scene key, which is a key to the object, nested object in the scenes object, which is already nested in the greater story object. So the scene key goes to an object, and the object has text, which is the text presented to the user. It has a scene summary, so it tells you where in the story you are. And then it has a list of choices. And these are the choices that the user can take. And each choice is an object. And each object has a text. So in this case, take the road up the hill. So this is like what the user could choose. And then a scene key, which is if the user chooses this scene, then it'll go to the next scene. Um, so for example, here we have three choices, and if they chose the third choice, the scene key would be knocking on a small brick door. The next, or small brick building, the next scene that they would be presented with is the text in here. Um, and so here, these are presented in, um, let's see. So in the infinite story code, and I think the infinite story code went offline, but I think someone was able to put up a copy. And if people don't have a copy of the code, I have a copy, and Chris has given me permission to send it out if needed. So
Yeah,
uh,
I've already sent out the link and then posted
great.
the link in the main forum as well.
Okay, great. So there are a few parts to this, but we can start with that data part, which contains the story objects, like I said before. So here we can do the small one. So we have that plot, which is the general text, and then we have the object of scenes, and then where each scene has the attributes text, scene summary, and choices. So we can just start with um, the first task, which is just a warm up, is to find all the scenes that have dead ends. So that are all the scenes that are dead ends. So that means we need to find all the scene keys that aren't in the scene's object um, as keys. So again, each of these choices has a scene key, and if a user chooses that scene key, we want to go find it in the scene's object. Um, but in this case, some of the scene keys may not be in the scene's object. And that's because, again, at the end, we're going to generate these scenes using ChatGPT. But for the warm-up, um, I've already coded it in here, but maybe we can walk through it again. So the first task is sort of loading the uh, content from JSON. So to do that, we need the file name, which I'll start with the small file. And then we need to use this JSON library, which is a Python native library, to open this file. And so this line is given to you in the assignment spec. And let me also, I'll just send um, I sent the link to the assignment if people didn't have it, just so they can open it if they want. So now what this does is we've loaded the story data into a Python dictionary, so we can parse it as a dictionary. And then we need to find all the scenes that don't have sort of scene objects. So these are all the scenes listed in the choices that don't have objects. So for that, we can start by just taking all the scenes. And so this will get us that object of objects, which is that scenes object. And so remember, in scenes, you have like a scene key. Uh, and this goes to like an object with choices and text. And I think one more thing, but those are the real important parts here. Um, and so the first thing we can do is we can get a list of valid keys. And so you know a key is valid if it's in the scenes object. Because if it's in the scenes object, um, then you know that it will have a corresponding object uh, that represents the scene data. So we can say valid keys equal list. So I'm casting this scenes.keys. And so just remember that scenes in this case is a dictionary. And so you can get the keys of a dictionary by calling this .keys function at the end of a dictionary. And then it's not natively a list, even though it acts a lot like it. So I'll just cast it to a list. So for now, we can just print valid keys. So I can say Python 3 warmup.py. Yeah, and you can see that here are all the keys that exist in the sort of small story. So these are all the scenes that exist, therefore. So now what we want to do is find the invalid keys. And so these are keys that exist in the choices, but don't exist in this greater scenes object. So remember, each of these scenes has a list of choices. And so now we can go through all of the valid keys. So we'll just loop through it. And then we can get the scene object, or the scene dictionary, by getting it. And we already know that this key will be in the scenes object because we got the list from the object. And then we can get choices. So the choices are sort of represented by choices. And remember that these choices go to a list of like different scene choices. And we can print them out just so we see them again. So it's a little bit hard to read, but you can see that each of these choices has a sort of text object, or a list has objects within them. And then they have this scene key and this text object. And so what we really want to do also now is loop through choices. And that will get us each choice in choices. And then we want to get the choice key because that will give us what's basically a pointer to the next object or the next scene. And so if we print out all the choice keys, you can see here that here's all of the choice keys that exist in the choices object. Now, the problem is that we're trying to solve. There are some keys in this valid keys that are not in this choice key or so there are some keys in this that will be in this printed list that are not in this valid keys. So does anyone remember how we can check if an object is in a list?
There is some command you can say if it's like in a list. I mean, I have to use ChatGPT to get the actual grammar, but
No, I totally do too, but you're spot on. We can check if it's not in valid keys, and this is how we know it's an invalid key. So we can create a sort of list of invalid keys to add to, and then we say like if it's not in the valid keys, then we can just add it to invalid keys, um, and then we can print the invalid keys. And here we have a list of all the keys that appear in choices but don't appear in the object. And so this is a warm up, and you can see here we had to go through a lot of sort of parsing um, of this like big nested JSON structure. And so this is why it's like really important that at the beginning, when you're sort of looking at things like this, and this is also relevant to APIs because they're often coming in a very sort of convoluted structure, that you understand how this big object of data works, so that you can properly get the right information that you're looking for. So that was the warm up. And to move on, we can go on to sort of step two, which in this case is printing a scene to the console. So here we want to create a function that takes, let's see. Yeah, we want to create a function that takes in one of these scene objects and then prints out something that looks like this, where this top text is the scene text. And then each of these is a choice for the user to select. And these will come from the sort of choices list. We can go back. Um, and now we'll start in this infinite story Python library, or not library, file. And I've made a few changes to um, the like beginner files that the assignment gives you. The first thing is I changed this used to be not OpenAI, but instead I changed it with OpenAI because not OpenAI um, is a library that Chris built specifically for CS106A, and it takes a different type of API key that we don't have access to. Um, and then I've added my OpenAI key in at the top. Um, so here we have story data, and what we want to do first is we want to create um, a, a file that's going, or a function that's going to print the scene. So the function will take in the scene data, and then we first we want to print the text, and then we want to print the each choice. So we can first get the text, which is scene data text. And then we can just print that. I'm going to turn off my completions because they're getting maybe a bit distracting. Um, and so this will print out the text, and we can start also just by calling this function with story data. Remember, we have that scenes object, and then within that scenes object, we have a scene key, and the starter key, we can make it its own variable actually. Starter key equals start. That will be the case for uh, every story given, and that's offered by the spec. So starter, and then after that, we'll have to print the choices. And so this is pretty simple. We can get the choices, and then we can just have a for loop that will run through them and print each choice as text. And so you can see I'm using this enumerate function, which just takes a list and gives you allows you to loop through both the index, which is IDX, and the element in the list, which in this case is the choice. So that easily gives me this IDX, and we're gonna add one to it because we're one indexing instead of zero indexing. And so if we run this, let's save it first. Yeah, okay, great. So now you can see we have infinitestory.py. Um, it gives us the starter scene text, and then it gives us our three sort of options. And so now we can go back so that we've completed milestone 2. Um, and
I don't want
I'm sorry. And now we can move on to milestone 3. So milestone 3 is get a valid choice. So get a valid choice. This wants us to create a function uh, which takes in scene data like the print scene does, but it wants us to take an input from a user as a valid choice. So first, we can print the scene. Whoops. Can print the scene data. But now we have to take in input from the user. So um, the data that we need for this is we just need the user to put in a valid index. So that will require us to, one, figure out what this amount of choices is. So I'm going to have this amount choices option. And then we can just take the length of the choices. And so this is going to get us the range of which the user can put in correct index. And then what we want is we want to get the choice from the user. And so to get the choice from the user, we'll just take an input. The first string to ask is what do you choose? And so this will give us a choice. But the problem is here, once we get this, we don't know if this is actually a good input. So instead, to check that, I'm going to have a while loop. And so we need to check three things, really. We need to check like if it is a number, first off. And then we need to check if it's above 0. And then we need to check if it's below the length of choices. And equal to or below because we're doing one index. We're sort of adding one. And so we can do this with checking first that the choice is not a digit, or is a digit, sorry. But this while statement, this statement right here is going to be if we need to get the information from the user again. So we can negate all these and check if any of these, if the opposite of any of these are true, then we'll need to get the information from the user again. So first off, we can check if they didn't even give us a digit, if they gave us a string or something, we can say we'll need to enter this while loop. Or if the int of the choice, and then we'll have to add one, or yeah, if int of the choice plus 1 is greater than or equal to 1. Oh, this is actually incorrect because we have to subtract 1 because remember, if the user puts in 1, they actually want index 0. For example, here, this in the list is at index 0, but we list it as 1, so we'll have to subtract 1. So if choice minus 1 is less than 0, that means that they've gone below, or in choice, and then we can subtract 1 again, is greater or equal to the length of or in this case, amount choice. And so we'll only enter this loop if the user doesn't give us a digit or they give us a digit that is out of range. And if they do any of those things, then we'll just want to prompt them for another choice. And then I think in the spec, it says to use this string. Please enter a valid choice. But once we have a valid choice, after doing this sort of input sanitizing, we can then get the scene from choices by just taking the choice index of the scene. So in this case, we can have valid index equals choice and then subtract 1. And then valid scene equals scene data. We can access that choices list again and then get the valid index. And so now, and then if we return this, we can swap out this function here. And instead of just printing the scene, we can just make sure we input a valid index. So we can say, what if we put cat? And then it would say, no, that's not good enough. So then we'll say, what if we put 0? No, can't put 0. How about 4? And then no, not 4 either. And then if we do 3, it's a valid choice. So that's milestone 3. Are there any questions before we go on and get to sort of kind of some of the trickier stuff? Maybe I can check. Let's see. Okay, great. If there are no questions, we can move on. So this is we've gotten this far, which is great. But now milestone 4 is where it gets pretty complicated. So in this main function here, we want to add a sort of while loop. And we can make it infinite because we'll want it to be infinite eventually. And we can start by in this while loop, we'll want to get the choice. So here, I can share the spec real quick. And then I know I might be running up on time, but if we have a little more time, I can keep going and just try to get a little further. But please cut me off if I'm going too long. So in the infinite loop, we need to get the scene data for the current scene, print the current scene, get a valid choice from the user, and then update the current scene key. So we can go back and in here. So first we can start by getting the sort of current scene, which we have as start. So this is the starter scene. So we already have that. So then we can get the user's choice by calling this get valid choice. And what that's going to do is that's going to print the scene key and get the choice. And so we'll have this choice scene object. And then from there, we can get the scene key by taking the choice scene and getting the scene key. So this is the choice by the user, and it has, remember, it has the scene key and the text. For example, this text. And then we have the next key now. And then from there, we can just get we can set maybe we should rename this current scene because it will take the starter scene and we'll set it to the next scene, which will be, in this case, story data. And then we'll take the scenes object that has all of the scenes in it, and then we have our choice key, and we'll pass it through there. And so now, when we go around, our current scene will get printed out and we can keep going. So we can run it again. So here we have our three options. What if we choose to walk up the stream? And see here, we have a key error. So this key error is actually expected in this case, because remember, not all of the scenes, not all of the scene keys will have corresponding scene keys. And so this brings us to what is the fifth milestone, which is handling infinity. And so this will go back to our OpenAI API. So what we need to do here is instead of just getting the current scene using the choice key, because there might not be the choice key in this object, we can instead check if choice key not in the scenes object get new scene from OpenAI. And so here, what we need to do is maybe create a new function. Maybe we should do this in a function. So we can have a function called get new scene. And so in the spec, we can see that in order to get a new scene, what we want to do is print this suspenseful music plays as the story continues. This is to, I guess, kill some time between when the GPT responds. Then we need to construct this prompt to ChatGPT to generate the next scene. And then we need to add the scene to our story data object. And then once we do that, then we'll have a new scene in the story data object that has the scene key of the choice. And then they give us here the prompt that they want us to use. So here, the prompt, we need to pass in the scene key, the example scene, and the plot. And this is all to give context to ChatGPT about what it should respond in its response. So the first step is let's set our variable. So remember, we need a scene key. We need an example scene. And then we need the plot. Then we need to print something about some suspenseful music. And then we can create our prompt. And so here I have an F string, which is the prompt. And it'll take in these variables, scene key, example scene, and plot, and it'll splice them into the prompt to pass into ChatGPT. And now we need to use our API. And so here we have the API call. And so instead of using that request library that we were using before, we're instead using now ChatGPT's custom library implementation of the API call. So instead of using requests, we're just calling this create function and using the client that's initialized at the top with the OpenAI library class. And we can pass in the messages. In this case, we'll say it's coming from the user, and we'll pass in the prompt as the message. We'll set GPT 3.5 Turbo as the model, and then we'll ask for the response type to be a JSON object. And so this will hopefully give us the JSON object that we can add back into the story data scenes object. So this chat completion doesn't just give us the output though. We actually need to go through the dictionary. In this case, remember that great big response object I showed you at the beginning. We don't have to go through it again, but we have this chat completion object, and then within that, it has choices, which will just take the first one, and then we'll take the message, and then we'll take the content. And this will give us the information about the content. And this content comes as a string. So here we actually need to, even though it's formatted as JSON, Python won't just recognize it as a dictionary. So if we use JSON.loads, and then we'll take the response string, this will pass it this will parse the JSON, which is just text, into a dictionary. And then we can return. So we'll return new scene data. So now here, what we can do is we can pass in, we can sort of pass in, let's see, get new scene. We can pass in the scene key, which in this case is the choice key. We can pass in an example scene. And so maybe for the example scene, we can just choose start, which will be the first always. And then we pass in the plot. And the plot is just another attribute of story data. And it's in the outer. So now we'll have this new scene. And then we can augment this story data scenes object and set the choice key attribute. So the attribute at the key choice key will set it to new scene. So now this object of scenes will have a key, will have a scene for choice key. And so if we run this again, so before when we chose choice 1 to take the road up the hill, now, oh, I think I chose choice 2 before. So now we have another scene. And then if we descend into the valley, now it's generating. And now it's given us this great new scene from ChatGPT. So ChatGPT has generated this text and returned it to us via the API, along with 3 more examples. And so let's say we want to explore the meadow filled with colorful butterflies. If we run that, it'll go to ChatGPT again. And now it's given us more information. So more content and then more choices to follow. And so now instead of getting that key out of, or that sort of bad error we got before, this key attribute error, I think it is, or key error, yep. ChatGPT will just generate a new object and new text and new choices anytime we get to a point in the story where we don't have that information that we had before. So this, I think, is where I'll stop. We've gotten pretty far. There's a few more tasks that you can follow with, mainly going with some visual things. And I think it is also great because you can sort of experiment however you want with this OpenAI API, which is really fun. But yeah, I can stop there and take questions if there are any. But thank you
So,
guys.
TJ, there are, because I've been kind of monitoring the chat. So there are 2 questions. The first one is, for those of us who are destitute and poor, do we have to use that 3.5 version of ChatGPT? Can we use like a unpaid version and still be able to get the program to run?
Um, let's see. The answer is, I think, unfortunately, it's tough to find free large language models APIs online because large language models cost a lot to run. And so I don't know about other APIs that will give you this exactly.
Uh-huh.
I know that depending on your computer, you can run models locally, and that's free. I'll also say that this probably costed about like 1 penny to run. But I know that unfortunately, it's you do have to put down a credit card and things like
Is
that.
it actually illegal to share keys amongst people?
It's not, no, it's certainly not illegal. The risk there is that if the key gets out into the wild, some bad actor could have it and just use it and sort of maybe run up a credit card. But you can put limits on an OpenAI account. And so maybe I can see if I can I'll put like a $5 limit, which will
No,
be
I mean, because
enough
like
for everybody.
what I was thinking is if there's a limit, I'm happy to put, I don't know, like a $10 limit on it and then just post my key on the forum or something like that.
Yeah, yeah.
And then the second question is how is API answer gets stored into a variable every time?
So the API answer gets stored. So here's the code for that. So this chat completion, like this function is in OpenAI's Python library, and it's making that request call. So it's getting that request. Remember earlier how we used that requests library to receive the information. Um, it's doing this behind the scenes. So it's storing it as a dictionary, and then it's returning that to me, which I can just take because it's the return value of this create function. And so from there, I can, get this response string through the dictionary that the function provides me with. Um, and then using this JSON uh, loads function, it will take the string and turn it into a dictionary, and that I can store in a variable as well. Does that answer the question? Maybe I don't understand quite. Let's see.
That
How
question
is
was not
AP
mine. It was someone else's. I didn't.
gets restored into a variable every time? Yes, thank you, my man. How it's updated. How is it updated? Oh, I see. Well, it's updated because here, sort of in this, every time you call OpenAI's library, uh, you pass in this data, right? This like messages, role and content. And this content every time is changing. And so the content of the, meaning how we don't lose. Oh, so when we're updating the story data scenes object, um, the answers will be continuously stored in here. Once the program ends, these new answers that we've created will be lost unless we were to load it into one of these files, like sort of take this object and then sort of update these files. But for while the program's running, this object will continue getting these new scenes. And remember, these choice keys will be continually changing because ChatGPT will be generating new choice keys for us to store the data in the dictionary.
So, TJ, you went through the first five milestones, right?
Mm-hmm.
Okay.
Yes.
Um, and so just a request, would it be okay if you kind of monitor the main forum chat so that as people work or try this program in the next week or so, if they have questions and then they can post it into the main forum chat. Um, and then you might be able to give tips because I certainly do not know how to help people debug, and so hopefully people will not be emailing me, um, with questions on this program.
Absolutely. Yeah, yeah. I think the main forum is a great place to sort of communicate. So yeah, yeah, happy to continue looking at that daily and try to answer any questions that come up.
Okay, all right. Well, thank you so much for being here. And, if there are no more questions, okay, I think we should give our Berkeley speaker the same amount of time, although he's from Berkeley. So I just wanted to introduce Eli. Eli is a computer whiz who just graduated from Cal. And then I actually work very closely with Eli's brother. And then I had actually asked his brother if he could come and then talk to us about GitHub and then Jupyter, except his brother says he's too busy working on helping me with my data analysis. And so he recommended Eli. And so I'll have Eli introduce himself, and then he's going to teach us about GitHub and that Jupyter notebook. Okay, thanks again, TJ.
Thank you guys.
Yeah, so hey guys. Um, I'm going to be talking about GitHub and Jupyter Notebooks today,
Oh,
which
Eli, I'm going to make you a co-host, and so hopefully you can also share your screen whenever you want to. Okay, if
Okay.
you
Yeah, let me do that.
um
Yep.
cool.
Uh, Okay. Can you see?
Yep.
Okay. So, um, I'm probably not going to be able to see the chat. Actually, I don't think I can see it while I'm presenting. So if you guys have questions or there's questions in the chat, like leave them there, and then I guess Vicky can interrupt me and let me know.
Sure.
Um, but yeah, I'm going to be talking about Git and Jupyter today, which are two very useful applications for programming. And it's really interesting because in like a 4-year university, they don't really teach you how to use these things. It's just kind of assumed that you figure out how to use it. And so it's nice for you guys to have someone who can actually tell you how to use these things that are really important. Um, so yeah, I went to Berkeley 2020 to 2024. I got a bachelor's degree in computer science. Um, I also worked at a startup hedge fund for the last 3 years developing trading strategies. And my shameless plug here is that I'm currently looking for a job in software engineering. So if you happen to know anyone, you can reach out to me and let me know. Um, but yeah, so I'm going to give you guys kind of a general introduction to these two applications. And I think one thing that I'm going to be reiterating a lot in this presentation is that all of this information can be found on Google. And nowadays, it's really easy to find it on ChatGPT too. So if you have questions, pretty much any time you could ask ChatGPT and it's going to give you a good answer for it, especially for these things. It knows GitHub and Jupyter inside out. So the first thing that Vicky asked me to talk about was the difference between Git and GitHub, and what they are. So Git is what's called a version control system, which means that if you have a program that you're making, and you have a bunch of different files, you might want to create different versions of those files. Like, for example, when you, I guess like iOS is a perfect example. Like when Apple asks you to update your phone, if you have an iPhone, it says like upgrade to iOS 17.1.2 or whatever. That's a different version of their operating system. And if you don't upgrade, you can still, it still works, like if you use the old version. So basically, what a version control system does is it lets people use completely different versions of an application or of a program and keeps all of them working. So it's not like everyone has to upgrade to the new version. What that means for your application or whatever program you're making is that you can have a version of your program and then you can um, you can modify it and not be worried about losing your old changes. So let's say you want to try something experimental, and you're not sure it's going to work. You can make a new version of it and then using Git. And then if it's not working, you can just go back to the old one really easily. Um, so what GitHub is basically a website owned by Microsoft that stores your versions of your program. So they're just basically a cloud company that can store all of your Git versions. And so you can put your projects in GitHub and they save them for you. And it basically will provide a bunch of different tools to make version control easier. And it's kind of, I feel like this sounds a little hand wavy right now, like you don't know exactly why you might want to use GitHub, but once we do some examples, it's going to make more sense. Oh, I also should add that over 70% of programmers use Git. So it's really important and essential to know. And GitHub is the largest what's called remote repository hosting company in the world. The other thing that GitHub does for you is if multiple people want to work on the same program, like let's say you have a project, a group project, you don't all have to be on the same computer coding. You can all be coding different versions of the same thing, and GitHub will be able to allow you to incorporate those together. So that's kind of the other reason people use GitHub is like if you're at a company and a bunch of people are working on a program, then that's that's how you'd accomplish that. Okay, so now we're going to talk about some basic commands that you'd use with Git. All of this stuff is going to be done in the command line, which is like the terminal right here, this thing. Mine probably looks a little different from yours because I'm on Mac, but if you're not on Mac, it's going to be called like Windows PowerShell or whatever it's called on Linux. I'm not sure. And I'm just going to go through some basic commands. The first one is to check if you actually have Git installed on your machine is to do git version. So git dash dash version. And for me, it says git version 2.3.0. And if you don't have git, it's going to error. It's going to say, I don't know what git is. And then there's a link right here. Oh, actually, I'm going to paste the link to my slides in the chat so you guys can click on the links if you want. Chat. Okay, here's the link to the slides that I'm presenting. And then also, if you want to refer back to any of these things later, then you can use the slides. Could Eli comment? I can actually see this. Could Eli comment on using Git in command line versus using GitHub desktop? Yeah, so I actually haven't really used GitHub desktop, so I'm not exactly sure what it does. But usually when you're coding, Git in command line is not very complicated to use. So I don't think it hurts to learn it. But if it's hard for me to answer this question because I've never used GitHub desktop. I'm assuming GitHub desktop makes using Git a little bit easier. So if you don't want to learn all these commands that I'm about to talk about, then GitHub desktop might be easier, but you probably still have to know what these things are in order to use it. But yeah, when you're coding, it's easy because you can have a terminal open this thing right next to your code, and you can do version control while you're doing it. Okay, so the first command is called git init, and it's basically to start a repository from scratch. And what a repository is basically just a folder. So if you have a folder of a bunch of files and stuff and other folders, then you can turn that into what's called a Git repository, and it's going to save you all your, or it can save all your work if you put it in GitHub, and you can create different versions. So what that would look like is, actually, I'm gonna do the demo of these commands in a couple slides from now. So I'm just gonna talk about what each thing is. The next important command is called git add. Basically what that does is you're going to add which files you want to commit. And what a commit is basically just a snapshot of all your files at a point in time. So if you have a bunch of files you're working on and you want to kind of create a checkpoint, then you'd make a commit, and that's something that you can later go back to. And when you're using GitHub, which you're going to be using, you can take that commit and you can put it into GitHub, so then it's saved in the cloud and you don't have to worry about losing your computer or anything or whatever happens to it, because you can always get that back. So git add is basically like the staging area for a commit, and then a commit is the actual snapshot that it creates and saves it. There's also git status, which just tells you all the current information of what's going on. Git log is to see the history of all your commits. Okay, let's go to the next one. We are going to actually start the demo, and then we'll come back to the
Quick
new commit.
question, Eli. There's a question in chat that says, can you comment on using get in command line versus GitHub desktop, especially for beginners?
Yeah. I was talking about that before. I've never used GitHub desktop, so I don't really know exactly what that looks like. But I think that they're probably similar. And GitHub desktop probably just makes it a little bit more user-friendly than using the command line. But I don't think the command line is too difficult to learn. So I'm going to be going over the command line, and with that knowledge, you could easily try GitHub desktop. Okay, so let's start our, here's some more commands that we're going to be going through, but let's start our demo. Actually, no, we have a couple more commands, and then we can start the demo, and we'll add in more commands as we go. Nate says, oh, it doesn't have all the functionality. Okay, yeah. So now let's talk about GitHub, because all the commands we just talked about were git. And then GitHub is how you can interact with the internet and add these versions to the internet. And if you want to, then if you want to work with other people, then you're going to have to use GitHub, because that's the only way to get them your versions. So the first command there is called git clone, which is if you have someone else's repository and you want to, or some repository on GitHub, and you want to put it on your own machine, you would use git clone to do that. And let's start our example now, and then we can see how it goes. So the first thing we're going to do is start a repository. So I'm going to go to GitHub. I'm going to make a repository. You guys should probably all have GitHub accounts so that you can follow along, but if you don't, you can just watch and then you can do it later. So this is what the dashboard looks like for Git. We go to repositories, we click new.
So, sorry to interrupt, Eli. How do we get GitHub accounts?
This is GitHub personal. So you just go to the website and just click create account and put in your email or whatever.
All right.
Yeah, GitHub personal is totally fine for everything you have to do. So
do you mind zooming it out a little bit? Because it's a little bit hard to like read what's on it. No, zoom the other way.
Oh, in?
Yeah. Yeah.
Okay.
Okay, thanks.
Is that better or more? Okay. So what I'm going to do is create a repository. I'm just going to call it test, because, or we'll call it tutorial. There's a bunch of different settings you can look at. It doesn't really matter. I'm going to add a README, and then I'm going to click create repository. Okay, so now GitHub has created this repository for me. If I want to actually use it, I have to do what's called cloning it to my own device, because this repository is in the cloud right now, like GitHub owns it. So what you do is you click on this green button called code. You can copy the URL to your clipboard, go to your command line, and then you type git clone, and then paste the link, and then hit enter, and it's going to take that repository from GitHub and put it on my own machine. So now I should be able to do, oh, okay. So now if I list it, this thing called tutorial is here. So I can go into my new GitHub repository and see what I have there, which is just a README file right now. And now we can start trying to do some of those commands that we first talked about. So we can say, oops, we can say git status, and that's going to tell me some information about what's going on. And nothing's happened yet in the GitHub, so it's not going to really tell me anything useful. Okay, so one more thing we have to do before we can just use GitHub really easily is setting up SSH keys. So basically, so GitHub, like you logged into your GitHub account, if you've done that, and GitHub has to know who you are when you try to interact with it. Like that's why you give it a password. So if I am in my command line and I'm trying to talk to GitHub, I need what's called an SSH key. Because if I try to talk to GitHub from here, it's not going to know who I am unless I have the key. And setting up that is in these two links right here. For now, I don't really want to go through that because it's kind of complicated, or it's not complicated, but it might take like 10, 15 minutes, and I don't think it's really worth our time. But there's two tutorials right here. You could get you should be able to get it set up by yourself. So that first thing I did called git clone, that wouldn't have worked had you not set up your SSH keys. Okay, so let's start trying to do some things in this demo. So I'm going to make two files. So we don't install git that indexes entire machines, so we don't have to clone stuff, just push from terminal. I don't really understand the question. You do have to install git, but you will, once you install it, you will be able to push from terminal, which is what the plan is. You can ask a follow-up question if that's not a clear answer. Okay, so let's make two text files. You can use the terminal command called touch. And I'm going to say touch a.text. It's just a text file called a. I can write to it by saying open the file, and then I can write whatever I want. Let's say I put the name of an animal in there in that file. We'll say alpaca. I'm going to save it and then quit. And then I can read the file by using cat a.text. These are all just terminal commands. They're not git commands. You may or may not know them. If you don't know them, you could look them up, but yeah. Okay, so I've written this file. I'm going to also write one more file. I'm going to say b.text, and I'm going to write to it. I'm going to use a different way to write to it that's faster, called echo. And I'm going to put another animal, beluga whale, into the file. Okay, so now I have this other file. I have a.text and b.text. Okay, so now I'm going to do git status again. And looking at this, it's going to tell me I have two untracked files, a.text and b.text, and they're in the red. What that means is that GitHub knows what, or Git knows what the changes are that you've made to the repository since you've last made a commit. And since we haven't made a commit yet, it says, okay, you've made some changes here. You've changed a.text and you've changed b.text. So now what we want to do is we want to create a commit to save them. So you can do git add. That's the add command that we said. And then you type in the name of a file. So git add a.text, send it. And then if we do git status again, a.text is going to show up in green, and it's going to say changes to be committed. And I'm going to do the same thing for b.text. And if we do status again, we can see that we have A and B are changes to be committed. So they're ready to be committed. And now I'm going to commit them by doing this. We write git commit, and then you have to put a little commit message. It doesn't let you just create a commit. You have to tell it what you did. So to do that, you do -m and then my message. So I'm going to say I wrote two files, or I wrote files a.text and b.text. That's the message. Okay, so now that I've made my commit, that we just created a snapshot in time and we've saved all the work we've done, which was making two files with two names. If I look at git status again, it's going to say, it's not going to tell me anything interesting, but it does say your branch is ahead of origin main by one commit. And so what that means is that we've made a commit on our end, and GitHub has the older version of our repository because it doesn't know about the changes we've made yet. So what we would have to do is push those changes to GitHub. And so we can do that. Well, we'll do that later, but we would have to do that if we want our changes to actually be saved in like the website GitHub. Okay, so we just staged and commit. Now we're going to talk about the version control. So I'm going to add more files. I'm going to change one of the files we have. So I'm going to open b.text. And I'm going to change it to another animal that starts with B, if I could think of one.
Bat,
Bat, that's a good one. Okay.
badger, beaver.
All right, I think we've got enough now. Okay, so I just changed one of the files and I'm going to add a new file. I'm going to make it c.text. And I also can't think of an animal that starts with C because it's hard to come up with them on the spot.
Cat,
Yeah, cat. Okay, so now we have a file called cat, or that has the name cat in it. And here's our changes. Once again, if I do git status, it says we've modified, or we have b.text that we modified, and we have an untracked file c.text because we just made it. And now let's create a new commit. So we have, actually, let me address this question in the chat first before I continue. Svetlana says, sorry for stupidity, but adding committing doesn't mean pushing. And when committing is like making a point to roll back on, but from terminal, we do not type commit message to go with it. Yeah, so there's a couple different stages in GitHub that are creating, like give you more control, and adding and committing don't mean pushing. And that's not a stupid question at all. So committing is creating a snapshot of the files on your own computer. But if you want to save them to the cloud or GitHub, that's when you have to push them to GitHub, which we have not done yet. And if you are working with other people on your project, then they're not going to be able to see the changes unless you push them to GitHub, because then they can get them onto their own end. And adding is kind of just like a small stage where it's just choosing what files you want to include in your commit, like what files we change that we want to include. So I'm going to go ahead and create another commit. So I'm going to add, I have to add b.text and c.text. And so I'm going to do that, git add b.text and git add c.text. And if I look at git status, I see that there are now changes to be committed. And I'm going to make a commit. Say git commit -m and say modified B and added C, or created C. Okay, so now we have two commits. And what I was saying before is if you want to, the reason we create these snapshots is because if you want to go back in time to a previous one, then this allows you to do, then Git allows you to do so. So we can do git log, which tells us all the commits we've made. Here's a list that it tells us. The first one is the initial commit, and that was on github.com because that just happens when you create a new repository. The next one was our first change, which was writing files a.txt and b.txt. And the next commit was modifying b and creating c. So if we look at b.txt right now, it's going to say bat. And we also have this file c.txt. But let's say I'm like, okay, I want to go back to the beginning when we just made a.txt and b.txt. The way I do that is I have to do git log first. And you copy this, what's called a hash right here, this long string. And we do git checkout and then command V or paste that in. And what that does is it allows us to go back in time to look at an old change that we've made. Can you see, or should this be bigger? That's probably better. Okay, so now we went back to the previous commit. And so now if I do ls, which lists all the files I have, you notice that c.txt isn't here. And if I do cat b.txt, it's going to tell me that it's beluga whale and not bat. So what that means is we went back to an old commit. So that was kind of like the first big thing that you can do with GitHub. And now, if I want to go back to so I checked out the old commit. If I want to go back to where we were in the or where we were before with all of our changes, I can do git checkout again. And if I do that, then we can look at the log and see that we, oh, my bad. Hold on, I want to check out git checkout main. Okay. Yeah. So that was my bad. If you want to go back to where you your most recent changes, that's called the main branch. And so you have to type in git checkout main to get back to them. So that's how we switch back and forth. And for example, if we want to go back to when we first started the repository, we can take this commit right here and do git checkout that. And then if we ls, none of our files are there anymore because we just went back to the original checkpoint that we had. So I'm going to go back to where we were in the first place. And now we can see that we have a.txt, b.txt, and c.txt, which is all of our changes. So now let's say we want to, okay, so let's say we decided that we want to go back to the previous checkpoint and actually use that as the one that we care about. Because all we did by doing checkout is just go and look at them. You couldn't actually make changes. You just were able to git checkout just allows you to see your old checkpoint and then like look at it, but you're not actually changing anything. So if we want to actually get like b.txt back to beluga whale, because right now it's bat. If we want to get those old changes, because let's say we made a mistake, what we do is we do git restore. And what we have to do is git restore b.txt. And this may or may not work. No, that doesn't work. How do I do this again? I'm forgetting exactly how to do something. Yeah, that's not gonna work. Okay. So, oh, sorry, that was wrong. Get restore is not what we want to use here. We want to use get reset. So, okay. Now we're saying we changed B and we added C, but we want to go back to when we just had A and B. What we do is we use get reset -- hard and then paste in this commit hash right here. And now if we look at our files, we have a.text and b.text, and that's permanent. We just got rid of our most recent checkpoint and we went back to an old checkpoint. Okay. So yeah, that's kind of a lot of the commands you can use with Git. Now let's say we want to actually save those changes in GitHub, which is pushing, like we had mentioned before. So if we do git status, we can see that our branch is ahead of origin main by 1 commit, and we have to use git push to publish your local commits. And what that means is to publish our local commits is take the ones on our computer, those checkpoints, and add them to GitHub. Because if we look at our GitHub right now and refresh the page, it still looks the same as when we first made it. But now I'm going to do git push. It's going to do a bunch of things, which is just taking all of our checkpoints and pushing them to the cloud. And then if we go to GitHub and we refresh the page, our changes should be here. So we can see that a.text is alpaca and b.text is beluga whale. And you can also see the commit message is right here. This is how we know which commit this is the most recent change to a.text is in the commit with this message. And now this checkpoint with all of this stuff is permanently saved to the internet. Okay, so the next thing that we want to do is, oh, actually there's one more thing, which is git restore. And we would use that if we have a current checkpoint, and let's say let me respond to Nate's question, which is, can commits and pushes be done directly within VS Code or even PyCharm? And the answer is yes. When you're in VS Code, you can do, I assume PyCharm's the same. I haven't really used it, but you can do all of the same things you're doing here, but with nicer buttons, because this is the command line where you have to type out all of this stuff. So let's say we have our most recent checkpoint, which was a.text and b.text. And now let's say I'm working on something experimental and I accidentally mess it up and I want to go back to my most recent checkpoint. So let's say I messed up my file, and I also messed up a.text and called it dolphin or something like that, or wrote dolphin to it. So now if I read a.text, it's going to say dolphin, and if I read b.text, it's going to say this jumble of letters. And now let's say I'm like, okay, this was all a mistake. I want to go back to my last checkpoint. I can do git restore a.text. And then if we read a.text, it's going to say alpaca again. And if I do git restore b.text, it's going to go back to my most recent checkpoint. And if I read it, it's going to say beluga whale again. So that's another useful command when you're working and you made some mistakes and you want to go back to your most recent checkpoint. You do have to be careful with all of this stuff, because if you do git restore and you didn't want to lose all of the changes you just made, you would lose them. So we can't, this jumble of letters up here that we wrote to B, we can't ever get that back. It's gone. So you have to be careful when you're using GitHub. Before we get to some more useful commands, I'm just going to add that ChatGPT is really good at GitHub. And so if you're like, oh, I don't remember how to do something that was talked about in this presentation, you can just ask it any question and it's going to know. So let's say we're going to try to get it to tell us git restore. So I'm going to tell ChatGPT I'm using GitHub, or I'm using Git and made some mistakes with my files and want to go back to my recent, and want to change them back to my most recent commit. And it should tell me. So that's one option, is git reset, like we talked about. It didn't actually talk about restore, but that was there's kind of a bunch of different ways to do things in Git, and restore was the way that I liked, but you can also do that. If I ask them what about git restore, it should talk about it. Oh, the reason it didn't talk about it is because it's a new command. And it restores a specific file to the most recent commit, which is what we wanted to do. And it's going to give you like a bunch of different ways to use a command. So yeah, I would encourage you to use ChatGPT if you want to remember how to use these things, or you can just Google it, and Google knows as well. Okay, so let's go back to our presentation. Yeah, so we have Git. So we've talked about Git init, Git add, Git commit, Git status, Git log. We haven't talked about branch, but we have talked about Git checkout. And we haven't talked about Git merge. So Git branch is not that useful when you're working by yourself, but if you're working with other people on a project and you want to say like, okay, I'm going to work on my own things for now, and I want it to be completely separate from what everyone else is doing, you create what's called a new branch. And so I could say git branch, and then I'm going to put, let's say, what I want to do on this branch. So let's say I'll just say my name, Eli branch. And then in order to, so that all that did was create a new branch. In order to start working on that branch, we have to check out that branch. So git checkout Eli branch. If I do git status, it's going to tell me I'm on branch Eli branch and nothing's happened yet. So let's say I make some changes, like I make a file d.txt, and we'll say dog. And then we check git status. It's going to have d.txt. Let's say we like create a commit. So I'm going to do git add d.txt and git commit wrote d.txt. If I then, okay, so now we should have that change. In our git log, there's d.txt. And I can go back to the original branch if I want to then look at like what everyone else is doing. So this was kind of just, I created my own experimental branch. And now we want to go back to the main branch, which is where we started. If we look at what we have, we won't have d.txt because that was only done on Eli branch. And if we want these changes on my branch to be reflected in GitHub, we'd have to go back to Eli branch and then push them to GitHub. And it's going to say that it doesn't know anything about this branch, so we just have to copy and paste this command that it gave us. And now it pushed it to GitHub. So we can go to GitHub and refresh, and we can see that there's now 2 branches. If I click on that, it's going to tell us there's branch main, which is the original one that we start with, and then there's also Eli branch. And if we look at code, or if we go back to branches and we click on Eli branch, then we should be able to see that there's a d.text right here, and we could actually read it. It says dog. But if we go back to branches and then we go to main, we'll see that d.text isn't there. Okay, so the next thing I want to talk about is pull requests. As you can see these words right here, compare and pull request. Let's say you've been working on this new branch called Eli branch, and you want to combine it with the main branch because now you're done with your work and you want to put it into the main project, which is like what everyone else is using, assuming this is a group project. You hit this green button, compare and pull request. You can add some description and title and then hit create pull request. And now we can do what's called merge pull request, where we take all the changes we've made and put them onto the main branch. So I'm going to hit that and then merge. And then I'm going to go back to my branches, and there should only be one now because we took the new branch, Eli branch, and we merged all the changes into our main branch. Okay, so now we have d.text here. And you're going to notice that on my own end in the terminal, if I'm on the main branch, I won't see d.text. And the reason for that is because the changes only happened in GitHub, but my local machine doesn't know about the changes that have happened in GitHub yet. So I have to do this new command called git pull to get that information. And it's going to add in d.text because on GitHub, we merged that branch into the main one. Okay, so that's pretty much the main commands you're going to need in Git. I think that's kind of, yeah. Yeah, that's most of what we need to do. The only other command or thing I would talk about is called fork, which is if you want to create a copy of someone else's repository, like let's say we're on GitHub and we found someone's work that we want to use, you'd hit the fork button. Let's see if I can find an example. I can't look at it in my own repositories, but it'd have to be in someone else's repository. So let's say actually we don't have to do that. We could, yeah, we don't need to do that. But yeah, that's kind of a general example of Git. I have a little class activity we can try here if we feel like we have time to do so. And I think we probably do. But before we try the class activity, let's ask if we have any questions that people want.
Yeah, so there are 2 questions in the chat. If you just scroll down way to the bottom of the chat,
Yeah.
says, can commit and push be done directly within VS Code or even PyCharm?
Yeah, so I talked about that one,
Okay.
which was the answer is yes. You can do, instead of doing all of this in command line, you can do it in VS Code instead. I don't need to show you how to use that because not everyone uses VS Code, but you can Google it and it's going to tell you how to do it.
Can you also do it in PyCharm?
It should work in PyCharm. I don't know the answer, but I would assume so.
Okay.
And then
I have a question, Eli. What is
Yeah.
the difference between clone versus fork? Because couldn't you use clone to copy someone else's code?
Yeah, so the difference is that clone is if you want to change, if you want to take the repository on GitHub, put it on your own device, and actually make changes to that repository. So let's say you're working on a group project and you're in the group and someone made a repository, you're going to do git clone and take that repository so you can make changes to it. Fork, however, is if you want to create like a copy of it that they're never going to see the changes you make to it. So let's say you find like a random project that someone has made out in the world on GitHub, and you want to, and you're like, oh, I like what they did here. I'm just going to copy it. You do what's called a fork, not a clone, because a clone would be, I'm going to make changes to their project. And a
Oh.
fork is like, I'm going to create a copy of it on my own end and then make changes to it.
So I guess clone, despite the name, does not duplicate a copy. It
No, it's confusing. It's the reason it's clone is because it's taking it on the remote server of GitHub and it's putting it on your local machine, like that project.
okay. So I guess a follow-up question to that is, okay, suppose I created something, right?
Yeah.
And put it on GitHub, and then I don't want like a bazillion random people to like clone and make changes to my code. Is there any way you can protect it from being cloned by other people who are not your
Yes.
collaborators?
There's two things. So the first thing is that people will, when they clone it, they can do changes on their end, but they're not going to be allowed to actually upload those changes to GitHub. Um, what they could do though is they could make a pull request like we talked about, which is just basically they're requesting to officially make changes to your code. And you, as the owner of the repository, will be given the option to approve that or not approve that. So that's the first thing. And we just did a pull request, but it was kind of trivial because I'm the owner of the repository and I requested to make changes to it. So that's kind of one thing. The other thing is you can make your repositories private to the world. So they're either public or private. So we're looking at my repository right now. If I go to settings and figure out where it is, and actually this is a good example of using ChatGPT. Let's say I don't know how to make my repository private, but I know I have to do that. I can ask them, make a Git repository private, and it should tell me how to do that.
Okay. And then just one last question, sorry. Do you know of a good, concise summary of all of the main GitHub commands, like on a website somewhere other than ChatGPT?
Yes. There are lots of Git tutorials out there. I could either look for one right now or I could look for one
Well,
later and
you
send it to
could
you.
send me one later, and then I'll just
Yeah.
like email to the group. Okay.
Yeah, that's probably a good idea.
Oh,
And also the other thing I would add is this slideshow that I made has pretty much all of the main commands you
oh,
will need
cool.
for GitHub. And if you look at this and you're like, oh, I don't remember what git checkout does, you can then just look it up or
Cool.
use a tutorial. Either
Okay.
works. So we were talking about making a repository private, which if we go to settings and then go to the bottom, we can change the visibility and then change it to private. And then nobody else in the world can see my repository anymore. So if you don't want anyone like reading your code, then that's another thing you can do.
Okay.
Um,
Um, just make one announcement. Feel free to go until whenever. You're the co-host now, okay?
yeah,
I actually have to hop off at 2:30 for a different meeting, but I will leave this Zoom running. And so however long you need, it will like continue to, I think, like record the second part, which is the Jupyter
okay,
notebook. And then once you're done, I think all you have to do is just shut off the Zoom and then it'll stop.
okay, yeah,
Okay,
cool.
thanks.
So let me answer this last question in the chat here, and then we're going to skip over the class activity because I don't think we really have time for it. But if you want to do it on your own time after, you can follow these instructions, and it's kind of just going to give you an example or a chance to test out the things that we've done. The last question is if we want to go from local to cloud, we commit / push, and when we want to go from cloud down to local, we pull. And yes, that is exactly correct. When you have stuff in GitHub, or sorry, if you have stuff on your own device and you want to make a checkpoint and then put it on Git, you're going to do git add, then git commit, then git push, all three of those separately. And if changes were made on GitHub, like for example, you went and you made some modifications here on your own, or you have someone else in your group who made some changes and you want to get them, you do git pull. So there's kind of this pulling from GitHub and then pushing to GitHub. Okay, and then let's do a quick summary of Git, and then we're going to start talking about Jupyter. Okay, so this is just like a screenshot. I didn't make this, that I found, of just a general summary of Git. Basically, it lets you manage projects with repositories, and a repository, if you remember, is just like a folder of files that you have. You clone a project to work on a local copy of it. If you want to, if you have some work that you want to save as a checkpoint, you're going to stage it and commit it, which is the same as add and commit. Branch and merge are a little more complicated, but that's like if you want to kind of keep your work separate, like you're trying to do something experimental, you want to do a task, you're going to create a separate branch for it. Pull is to get the latest version of the project from GitHub, and push is to take your local updates and put them on GitHub. Yeah, and then the only other thing I'd add is that you can, the reason GitHub is good is because you can use that checking out and restoring and resetting to go look at old changes that you have and go and get back to them. Okay, so let's start talking about Jupyter. I think that's kind of my general summary of Git. If you have any other questions about it, you can leave them in the chat. Okay, so Jupyter Notebooks is another way. It's called an IDE, which is an interactive development environment. And it's just another place that you can write code instead of like VS Code or PyCharm or whatever other IDE you use. The reason Jupyter is particularly good is because instead of running an entire file, it splits your file up into little cells, and you can run those pieces separately. So for example, let's say you're doing like machine learning, and the first thing you do is load in this data set that takes a long time to download, and then you're going to do some work with the data set. You only want to load the data set in once. You don't want to have to keep doing that every single time. So you could use Jupyter Notebooks and have one cell load in the data set, and then the next cell you can do some work with it, and you never have to, or you don't have to rerun that original cell. The other thing that Jupyter is good for is that it shows, if you want to have a lot of charts and graphs while you're coding, it makes it really easy to show them. This doesn't apply to everyone, but if you've been coding and are making charts, then it's kind of hard to see them when you're coding normally, but Jupyter puts them like right there in front of you while you do it. So that's the reason that you do it. I asked you guys to install Jupyter Notebook ahead of time. If you have pip, you just do pip install notebook, which mine's going to work because I've already done it already. But if you haven't done it, it might take a little longer than that. And once we have Jupyter Notebook installed, in command line, we can write Jupyter Notebook. And actually, I'm going to go back to, okay, now I'm going to write Jupyter Notebook, and it's going to open up my notebook. And basically what it does is it opens it up in your browser, like Chrome, but it's still all happening on your computer. So what's happening here is my computer is running Jupyter Notebook, and then it put it in the browser, and every time I click on something in here, it's going to make changes over here that you could see if you want, but you don't have to look at it at all. Okay, and so once I have Jupyter Notebook open, I would click New, and then Notebook, under Notebook, click Python 3 because we're going to be coding in Python. And this is what Jupyter, no, whoops. Hold on. Okay, this is what Jupyter Notebook looks like. So I'm just going to give this, call it tutorial. And then now we can start coding. So we can write Python code. I could do a print statement like print hello world. And then you could either click run to run this cell, or you can do click shift enter and it runs it automatically. So I'm going to write shift enter to run a cell.
Sorry, Eli, how did you go from installing Jupyter Notebook to the web-based of Jupyter Notebook?
Yeah, so do you have it installed?
Yes.
If you, oops, if you type in Jupyter Notebook into your command line and hit enter, it should open up in your
Oh, website. Okay. So, so I guess in other words, Jupyter Notebook is entirely a web-based IDE.
yes, the whole thing is web-based. But just because it's web-based doesn't mean you are not working on your computer. Like it's still, your computer is still handling all of the things that's happening. But it is on like Chrome.
Okay. And so we don't run Jupyter Notebook from terminal or command line.
You don't
Right.
have to, yeah, you just, this is just, you only do that to start it up.
Okay.
Like to get to this web page or this web page right here, you have to go to command line, type in Jupyter Notebook, and then it'll take you here.
And then once you're at that page, what do you select? Console, notebook, terminal, text file, markdown file, Python file?
I hit new and then I hit Python 3 under Notebook.
Wait, so you hit new Python. Okay, mine look a little bit different.
Yeah, you could share your screen actually, because I'm sure other people have the same situation.
Okay, I'm on a Mac. Okay, and
Yeah. And also, hold on, just to interrupt you, to answer Nate's question in the chat, the link that I sent for Jupyter, or the link that I sent for Git, is also the same link for Jupyter Notebook, so you can stay in that same thing.
okay.
Okay, so
So I'm on a Mac, okay, and so this is my Jupyter Notebook page. And then if I go to File, New, these are the different
yeah,
options.
so you would click Notebook, but also see on the right side, like the top right or right corner of your page,
Mhm.
it says New to the right. Move your mouse to the right, right.
New to the right
Like keep going to the right.
here. Oh, here.
Yeah, there's a
Oh, oh,
so before you do that, I'm just gonna add that we're looking at, see all the folders below. Those are like all of the folders on your computer. So you
yes.
probably
I have
want,
a very messy desktop, so
yeah, no, it wasn't like calling you out, but you probably
it's
don't
fine.
want your notebook that you make to just be sitting like in the abyss on your computer. So you might want to make a folder ahead of time for where you want your Jupyter notebook to go.
Okay.
And but
So we want this Python 3 IP kernel,
yes,
not from the file here.
it's the same thing if you were to click, wait, yeah, if you click notebook, that would be the same thing as on the other side.
As a Python. Okay,
Yeah,
cool. Thank you.
it's the same thing.
Got it.
Okay, so I'm going to continue sharing. So yeah, hopefully people have a notebook open. And also wherever you run Jupyter Notebook from, like in the command line, whenever you write Jupyter Notebook, it's going to open the folder that you're in when you run it. So in Vicky's case, she was like in her home directory and she wrote Jupyter Notebook. But you might want to make your own folder and then go to that one. So I would go to the lesson that we're working on right now, and then I would run Jupyter Notebook. And then when I enter that, it's going to open this web page with some folders. And mine is it's pretty empty right now because it's a new folder. Okay, so let's continue talking about things that you can do in Jupyter. So that I already told you how to run a cell. If you want to delete a cell, you can hit escape and then type DD on your keyboard and it's going to delete it. That's also in my PowerPoint right here. There's just a few commands that I left. If you want to add a cell, you hit escape and then type A, and it's going to add more cells. And before we get coding, the only other thing I'd say is these right here are called coding cells. If you want to change the type of cell, you can go to cell and then click cell type. And then instead of code, we could make it like a markdown cell, which is if we want to have a title. And then I run that, it's going to look like this. And instead of code, it's just like if you want some words. So if you just want to put text, then you make it a markdown file or a markdown cell instead. Okay, so that's just a general, like this is just how you open your notebook. Then whatever code you write is kind of up to you. I have my own little demo that I'm going to have us go through for just like something that we could do with code, but it doesn't, you could do whatever you want in here. The only important thing is that it's nice to use Jupyter because of all the separate cells for running code separately, but it's like it's the same as other IDEs. Okay, so oh, and the other thing I wanted to talk about before I get into my demo is called Jupyter Hub. So think like GitHub, but for Jupyter. If you want to, like let's say you're in a class or you're at some company, they can have a Jupyter server, which basically will allow them to give you Jupyter notebooks that you don't have to run on your own computer. So that's, if you want to do Jupyter remotely, then Jupyter Hub would be the way to do so. You don't have to know how to set it up. It's possible that someone else might send you a link to a Jupyter notebook and you could just click on that link and you could run Jupyter and it's going to work and you didn't have to do it on your own computer. Okay, so let's get into the demo. First, what I wanted to do is just get some imports in here. Oops. Actually, before we do that, I'm just going to show you how easy it is to, so first I'm going to do some imports. So I'm going to do import numpy as MP.
Question. There's a question in the chat that said, how do we prove from losing data due to limited time of kernels running 90 minutes? I don't know what that means.
Yes, I can zoom in. How do we prove from losing data due to limited time of kernels running 90 minutes? Why can your kernel only run for 90 minutes?
Yeah, that's weird.
I think it should be able to run as long as you want, but basically you won't lose anything as long as you've saved. So up here, see it says last checkpoint 9 minutes ago, unsaved changes. If I do Command S and save it like a normal Google Doc or whatever, then it's going to save it, and then I don't have to worry about losing anything. It was cloud hosted Jupyter notebook with limited CPU. Okay, so yes, what you're talking about is a cloud hosted Jupyter notebook. That's like Jupyter Hub, what I was talking about. So instead of Jupyter running on your own machine like we did here, where we went to our command line and we typed in Jupyter notebook, you might get a link to a cloud hosted Jupyter. And since you're using someone else's computer because it's a server, they probably will give you limits to like how much CPU you can use and how long you can use it for. And if they set it so that you only had 90 minutes, then that's kind of all you can do. And if you save the notebook, you shouldn't lose it. Okay, so let's continue. I'm going to add in some more imports. It doesn't really matter exactly what they are. So you can add these on your own end if you want. I have a couple more that I need for my demo. Okay, and so now if we run this, if we do Shift Enter or click this Run button, it's going to run this cell and import all of these libraries that we need. And it's very likely that you don't have some of these libraries. Like it might say, I don't know what NumPy is. So what you can do is you can either pip install NumPy, like here, if you don't have it. Or in Jupyter, you can do an exclamation point and then do pip install NumPy and then run the line, and it's going to install NumPy for you. So this is just to get all of these imports to work, because you probably have not downloaded all of these things like NumPy, Matplotlib, Seaborn, and so on. Vicky, can you confirm that you are with me on this?
Oh yeah. Yes. I am with you on this. I've actually done this part before.
Okay, cool. So yeah, so that was getting our imports. And now let's say we want to make a graph. I'm going to graph a parabola, let's say. So I'm going to have my x's, I'm going to make my y's as an NumPy array. This isn't really something you have to know how to do. I'm just trying to show you how few lines it takes to make a plot. So if I do plt.plot, and then I pass in a list of x values and y values, and then I do plot.show, it's going to show me my plot, which looks like this. And this is just a way to make, this is like how I said Jupyter Notebook makes it really easy to see your graphs. It only took me 4 lines to graph this parabola. And we are going to do more graphs, and we can do pretty much anything. So here's the, let's get into the actual demo that I wanted to do. And it's with this data set called penguins. So the first thing we want to do is I'm going to make a markdown file, and I'm going to say we're going to load in a data set. So this is the title of what we're doing. I'm going to set this variable called penguins, and I'm going to do SNS, which is Seaborn. And I'm going to do sns.load dataset penguins. And then I'm going to run penguins.head to see the top of the data set. And basically what Seaborn is it's kind of the same as Matplotlib, if you've heard of that. It's just like a tool that you can use to plot data. But they also happen to have some data sets that you can play around with if you want to. So if we go on Google and we say Seaborn data sets, then it's going to say Seaborn load data set, which is what we just did. And it says, okay, here's a link to a lot of the different data sets that we have. So they have all these CSV files here. I happen to choose penguins. which is just a table with a bunch of information about some penguins that they had. But they also have tons of other, like mpg.csv is like about cars. So if you want to just play around with some data sets, you can use Seaborn. Okay, so the next thing you might want to do with some data is you might want to visualize your data. So I'm going to say, and I'm going to create some charts. And you don't have to remember how to do these, but these are just some different charts that you could make with Seaborn. So I'm going to do sns.histplot, which is a histogram. And I want to look at the different species of penguins that I have. And just to remember, I have to do plt.show. And now we can see it. Here's a histogram of the different penguins that we have in this table. So here is our table. We had this column called species. And here's the different species of penguins. We have Adelie, Chinstrap, and Gentoo, which I have no idea what those are, but that's just what they have. Let's say I want to do a scatter plot, and I want to compare like the bill length of the penguin with the flipper length of the penguin. I could do sns.scatterplot. And this is like not stuff I expect you to remember, but it's just nice for you to know that it exists. And you can ask Google or ask ChatGPT how to use different, like how to make a Seaborn scatter plot, and the first link is going to tell you how to do it. But we tell it what the X is going to be on our scatter plot. We're going to make it bill length. And then my Y is going to be flipper length. And then the data is the penguins table. And then if I do plt.show and I run the thing, it's going to give me a scatter plot. And if we wanted to learn something from it, we can kind of see that as the bill length of the penguin gets bigger, the flipper length also kind of gets bigger. That's the general trend I see here. Okay, so let's do, here's another chart that I want to do. Actually, has anyone tried to get these charts working and has managed to do so? If they're following along. Okay, I'll just continue showing charts, and then we're going to get to our actual activity. So I'm going to do a violin plot. I'm going to compare the sex of the penguin, so male or female, with the bill depth. And so here's our machine learning activity for this demo. If we look at this plot, this is giving us a distribution between male and female penguins. And we can see that the bill depth of the penguin is kind of a little bigger on the males. Like this is shifted, this distribution is shifted up a little higher than the females. And we could do anything we want. So we can compare flipper length if we want and run that. And so let's say the machine learning activity that I want to do is, given all this information about a penguin, species, island, bill length, bill depth, flipper length, body mass, and body mass, can we predict what the sex of the penguin will be? So let's say we wanted to figure out what the gender or what the sex of the penguin is, given all this information about it. And so we're going to do what's called logistic regression. You may or may not have heard of that, but logistic regression is kind of just a way to make binary predictions on data. So if we want to figure out if someone's male or female, given some information, we can do that. And so I'm just going to run through this really quickly using ChatGPT. So given the Seaborn penguins data set, use logistic regression to predict whether the penguin is male or female. And it's going to give me a bunch of code. We can copy and paste it into our notebook, and we're going to actually have something that can make predictions. So I'm going to just copy all of this in. Okay, so there's some pre-processing that happens here. We don't really have to know the details, but basically what's happening here is it's creating an X table with everything except for the sex, and then a Y table with just the sex of the penguins. So we can try to use those X's to predict those Ys. Then I'm going to split this into a separate. Let's get rid of that. pd.getDummies is not working. If it's not working, let's get rid of it. So as you can see, I'm kind of having to modify some of the things that are happening. Hold on. This ChatGPT didn't happen to work in this case. But if you make some changes here, it should end up working. And I did this earlier, and it did work. So I'm just going to copy the code that it gave me earlier, and run it. And still not working. Hold on. So this kind of happens sometimes with live coding, is that it doesn't always work exactly how you want it, but it just ran, and now we have our training data set. And it just has all the information about the penguin except for the sex. And then here's the separate Y values, which have the sex. Okay, so now we're going to make our logistic regression model. So we would do model equals logistic regression. And then we have to pass in this iterations thing, which is not that important. And then we can fit the model using our X training set and our Y training set. And that's just training the model. And now I can use our model to predict our X trainings or our X test set. And it's going to make predictions on what it thinks each penguin in the X test set is, or what the sex is. So one thing that's a little confusing that I might add for you guys is that it just output a bunch of zeros and ones instead of the sex. And that's because there's just this thing in machine learning that you don't want to have, like it doesn't say male or female, it's just going to say sex instead. Or it's going to say like a 0 or 1, so we turned the male and female into 0 and 1. And if we want to know what 0 and 1 are, we can look at the table, penguins. And it says right here, male is 1 and female is 0. So what we had here was our predictions for what our model thought the gender of each penguin was going to be. And let's see if it's right. So I'm going to just do a for loop and iterate through our data 10 times. And I'm going to print the prediction. And I'm going to put the I'm just adding this little function here. It's not really that important. Sex of Y prediction of I, and then I'm going to print out the actual prediction. Or the actual value of I. Okay, and now I can run this code, and it's going to give us the top 10 values in our test. So we predicted that the penguin was female, and it's actually female. Then we predicted that it was female, and then it's actually female. The third penguin we predicted male, and it's actually a male. So we can see so far that this is actually pretty good. Like our prediction is working pretty well. And if we want to know like what percentage are we correct on, there's something called, actually we can just make our own function here really quickly, and then we're going to wrap up this demo. So I'm going to make a function called accuracy, and it takes in a column of predictions, and it takes in what they actually should be. And then I can compare them to each other, so set when they're equal. And then I just want to know, this is going to tell us when each thing is equal, if it's true or false, and then I'm going to add all of those up and divide by however many there are. And that's going to give us an accuracy. So now I can do print accuracy of Y prediction and Y test, and it's going to tell us that we were 90% accurate, which is pretty good. Okay, so that's, I'm going to wrap up my demo here. That was just a little demo on Jupyter. I can give you guys my code for this demo, but it was basically, I just wanted to show you that things like machine learning and data science can seem very intimidating, but with a little bit of Googling and ChatGPT, you can do what I just did, which was take this penguin's data set, and we made a model that predicted whether each penguin was male or female. And we did so with 90% accuracy, which is pretty good. So 9 out of 10 times this model is correct. Okay, so I'm going to wrap it up there. I'm going to look at questions or see if there's any questions that people have. So leave those in the chat if you have questions, and then we can finish up. Blossom says, I missed the part if you covered it. When installing matplotlib numpy libraries by simply typing commands in Jupyter, does Jupyter then install them from the wild internet, pulling from any particular source? Leah said you have to install them using pip install, which is correct. Eliza asks, what's the difference between installing using commands pip install Jupyter Lab and pip install Jupyter Notebook in the terminal? Oh, okay, yes. So in terminal, if you do pip install Notebook, which is what I think I asked you to do in the first place, that is going to make it so you can then run this Jupyter Notebook like we are here. And I believe Jupyter Lab is like a similar product. Honestly, I think the answer, Eliza, is that they're basically the same thing. And Jupyter, whoever created Jupyter started a long time ago with Jupyter Notebook, and then they added some more things to it and called it Jupyter Lab. And when you install them, you can still just install one or the other, but they're basically the same thing. Yeah, does anyone have any other questions? I hope that the demo was useful and kind of showed you how to use Jupyter Notebooks. Okay. So Vicky wanted to know how to save. Jupyter Notebooks in HTML. Okay, yes. So to save a Jupyter Notebook, if we do Command S, it's going to just automatically save the notebook. Like if I go back to my folder in command line, or if you have Mac, you can look on Finder. And I go to wherever I'm doing this, which is in this folder right here. We can see this file called tutorial.ipynb. And that is the extension for a Jupyter notebook file. So anytime you save a Jupyter notebook file, it's going to be ipynb. And we can also see on our homepage here, we have tutorial.ipynb. So if I close this notebook right here, and then I click on it, it's going to open and have all of the changes we made. So if you want to save this as a different format, because let's say you don't want to work on your Jupyter notebook anymore, you want to like send it to someone so they can see it. It's a little complicated, but you can do file, you can do download as, and then you have any of these options. You can download it as HTML. You can try to download it as PDF, but usually that doesn't work for me. So I usually like to do print preview. And then this shows me at my entire notebook preview. And then if I do Command P to print, I can save it as a PDF. And then that's going to give me the entire notebook with all the outputs. And that's not to save it. That's like if you wanted to show the PDF to someone of your notebook. If you want to actually just save the notebook, then you just do Command S or File Save As, and then that's going to save it for you. So I'm going to get to Leah's question in a second, but first I'm going to answer what Svetlana asked, which was how would you host your Jupyter notebook on GitHub? Is that possible? And the answer is yes. So I'm going to show you how to do that right now, actually. So if you remember, so before we continue, I will add that Jupyter has a command line that you can use. If you do new, you can click terminal, and it opens a command line. But we don't have to do that. You can just use this one right here, which is the exact same thing. If I take this file that I just made, tutorial.ipynb, and I put it into my into my Git repository called tutorial right here. So I'm going to do what's called MV, which is just to take a file and move it. I'm going to move the tutorial Jupyter notebook file and put it into my Jupyter repository. And if I see here, it's not in this folder anymore, but if I go into my Git repository, we can see that we have our a.text, b.text, and d.text from earlier, and then our tutorial.ipynb. So now I can look at Git status, and it says, okay, we have this untracked file, tutorial.ipynb. And now I can push it to GitHub. So what I'm going to do is I'm going to do git add tutorial. I'm going to do commit and say, putting my Jupyter notebook into GitHub. And then I'm just going to push it. And then if I go to GitHub now and refresh, we should see that this Jupyter notebook file is right here in GitHub. And in fact, GitHub is smart enough to know how to look at the file right here. So that's how you do that. And then now GitHub is actually saving your Jupyter notebook for you. So you could clone this repository and then take this file and in Jupyter Notebook start writing to it. But if you just want to look at it, then you could look at it right here. Leah asked, do you have any tips for memorizing the commands? And yes, you're welcome, Svetlana. Do you have any tips for memorizing the commands? No, you just kind of have to practice. I put, like, you could keep this slideshow open when you're trying to use GitHub, and just like remember here that I put in 5 commands on this page, 3 commands on this page, and 3 commands on this page. So a total of 11 Git commands, which is kind of a lot, but that's pretty much all you ever need. So if you keep these open and you're like, okay, I want to do this in GitHub, just Google like how do I use git commit? And Google will tell you exactly what git commit does. And I think looking at this article is a little, actually Atlassian right here has all of these changes. It has, or all of these commands. It has git init, git clone, git commit, and it has like a bunch of other ones that I didn't even talk about. Like there's way more things than I've ever talked about. And the other thing I would add is I really like to use ChatGPT. So you can ask in ChatGPT, how do I make a git commit? And it's going to tell you exactly how to do so. So initialize a Git repository, add your files, and then it says make a commit, like git commit -m, and then your message. And then ChatGPT also gives you an example workflow. So it kind of tells you some different commands you write in terminal to then get some information. So I think that's kind of it's not a way to memorize the commands, but it is a way for you to start using GitHub and not have to ask someone how to do it. Yeah, so it's been 90 minutes, so I'm going to wrap up unless someone else has specific questions. But yeah, hopefully that was like a good introduction for you guys to start being able to use GitHub and Jupyter Notebooks. I know that the Jupyter Notebooks was like I went on that Penguins demo because that was kind of just a good way to see that you could do some data analysis if you want, and it's not too difficult to do. But yeah, hopefully you guys can start using these things. And yeah, I'm gonna leave the meeting now, so it's gonna end. All right, see you guys later.